Now we need to talk about how we do subtraction. Fortunately, we don't have to build an entirely different circuit to do subtraction. Let's start by reviewing 2's complement subtraction. Remember what we do with 2's complement subtraction is we negate the second operand and then we do addition. Let's take an example where I have 104 and I'm subtracting 17. What I do is I take 104 and then I add that to minus 17. So I form the 2's complement of 17. I create the minus 17 and I add that to 104. And then I get my result 87. Remember, this is a nice thing about 2's complement arithmetic. It doesn't matter whether they're positive or negative. They add together just like normal binary addition that we've learned. Now we can leverage the full adder that we've designed as well as what we know about 2's complement arithmetic to build a subtractor. First thing we need to do is we need to take the second operand and we need to negate it. We need to form the 2's complement. So here's how we do this in hardware. We have 4 inverters, one for each bit, in order to form the complement of each of those bits. And then we need to add 1 in the right-hand side. Let's take our adder now and convert it into a subtractor. So the difference here is, first of all, instead of feeding the b's in directly, we're going to negate those. So let's place inverters there. Okay, so now we have the inversion that we need for 2's complement. Now, how do we add the 1? Well, it's convenient that we have a carry in the right position, because instead of feeding a 0 there, we can feed in a 1, which is the same thing as adding 1 to our negated b. So our 2's complement is formed by these inverters plus forcing a 1 into the carry in the rightmost position. So here we have a subtractor. It's very similar to an adder. All we've done is we've inverted all the b's, and we force the carry in the right position to be a 1 rather than a 0. Now the adder and subtractor are very similar. So we can leverage the same hardware that we use for both and create one design that adds and subtracts. So here are the 2 designs that we have. We have an adder at the top and we have a subtractor at the bottom. Now what you see is the difference, of course, as I just mentioned, is that the b's are inverted and we force a 1 rather than a 0 in the rightmost position. So with a little bit of additional combinational logic, we can have one design that can add or subtract.